For example, a typical example you might have encountered this: a cell phone. When you are close to base station, the signal range is very good. So that is the all the signal bars in your phone, everything will be shown. So which is the maximum power your cell phone can operate. If you are far away from the tower, even if you are able to attend the call and speak, and the call quality is very good, that is the minimum power which your device can detect. So if you take the ratio of that, that is going to be the dynamic range. Okay, so that is the example of a cell phone receiver, which has these two bounds very clearly defined. So when you're close to tower, power maximum power is handled. When you are very far away from the tower, but still you are able to receive and make call successfully, that is going to be the sensitivity of the so difference between these two, or the ratio of these two, is going to be dynamic range. So math numerically you divide the power, logarithm you will subtract the power. That's why I say ratio or difference in power between the maximum power and the minimum power. So when you are going to have a lot of interference, when you don't have interference, dynamic range will be very good, because the entire signal power will be, the upper limit will be very high, the lower limit will be very less. So the broad value of dynamic range can be obtained. So this is just the name dynamic range. And the next one is called spurious free dynamic range. It is called as SFDR, which is going to have both the noise and interference. Noise is coming from the device, interference is coming from other users. So when you consider only noise, it is dynamic range. When you consider it is coming from both noise and interference, it is called as SFDR. In enhanced version of this name, it is called as spurious free dynamic range. It is called as SFDR. Remember, when you say SFDR, it is going to consider the effect of both noise as well as interference.